Hey guys, Mr. Gucci here to do a part two. Okay, yeah, part two of the 1.4 notes, which in this case we're going to talk about the scientific method. Okay, now this is you're in 10th grade, so probably you've been taught the scientific method every science class for like the last 3 or 4 years. We're going to give it like one more go around right now. Okay, and let's just focus in on the scientific method and its steps. Now, it seems complicated. The scientific method seems like it might be complex, but in the words of Adam Savage from Mythbusters, the difference between screwing around and science is that you're just writing stuff down. Okay? And so the scientific method is not complicated. The scientific method is just a way to know how the natural world works. And it's four basic steps. Step one, observation. You observe something about the world that you think is interesting. Step two, hypothesis. You think, I wonder if this is how the world works. This is my idea of how the world works. Step three, you experiment. You're testing your idea to see if it's right or wrong. And then step four, you just make a conclusion. My experiment proved that my hypothesis was probably correct or probably wrong. It's just coming up with an idea and then testing it, right? Like, that sounds like pretty common sense, but a lot of people don't actually test their ideas. A lot of people stop at the stage where they just make a hypothesis, all right? They just think about it for a little bit and then they're like, that's my idea. And they never bother to check it. Okay. So here's a really interesting scientific question right now. How do we know that masks help prevent the spread of COVID? Let's look at the scientific method and see how this idea is addressed by the scientific method. Okay. So the first step is observation. You make an observation about how the world works, and this observation can come from anywhere. There's no right or wrong way. It could be something you heard, an experience that you had, or something you remembered briefly as a child long ago. There have been some scientific discoveries that started off as dreams that scientists had. And they're like, I had a weird dream about this thing. Let me investigate it further. That counts. Observations can come from anywhere. So here's an observation. Doctors have worn masks for decades, perhaps even centuries, in order to reduce infection rates in hospitals. All right. So if it works for doctors, why wouldn't it work for people? If doctors wear masks and it helps them, maybe people should wear masks and that'll help prevent the spread of COVID among their population as well. By the way, this mask up top here, this is an authentic plague doctor mask from like the 1500s. Okay, even then they kind of knew, maybe if I breathe this bad air, I might catch a disease. I should try and do something about it. Okay, so that's the first step, an observation that comes from anywhere. There's no such thing as a bad observation. But the next step is to come up with a hypothesis. You need an idea, an educated guess about how the universe works that you are going to test. And it is possible to have a bad hypothesis because a good hypothesis needs to accomplish two things. You need to, first of all, be able to test it. All right. If your idea can't be tested at all, maybe you believe that, invisible ghosts are stealing your socks out of the dryer, and that's why you don't have any more matched socks. There's no real way to prove that, is there? All right. Ghosts pop in from another dimension and steal your socks. If you can't see it happening, you can't really test it. A good hypothesis, you have to be able to test it, or you can't move any farther. Okay. Now, the other good thing about a hypothesis, the other thing that makes a hypothesis good is it has to be falsifiable. All right. You have to be able to prove it wrong. Now, this confuses a lot of people. I'm not saying that your hypothesis has to be wrong. What I'm saying is that there has to be some piece of evidence that you acknowledge that if you found this evidence, it would prove your hypothesis wrong, or at least not as correct. There has to be something that you could learn that would cause you to disbelieve in your idea. All right. If there's nothing you can hear, if there is absolutely nothing I could tell you, no evidence I could provide that would prove your idea wrong, then once again, there's no point in testing it. All right. There's no point at all in testing it. So here's an example. Wearing a cloth mask over the mouth and nose can reduce the spread of particles that transmit COVID. this is something we can test. We can put masks on people and have them do different things possibly and see how much stuff is spit out of their mouth. How much does the mask stop that? So this is something that we could prove. All right. You could show me evidence that says, hey, here's someone without a mask, here's someone with a mask, and there is no difference in the amount of particles they released. And I'd be like, well, then masks probably don't do anything. The next step is you need an experiment. Okay, an experiment is a test that focuses on proving your hypothesis wrong. And this is another stumbling block where people mess up. Your goal should be do everything you can to prove that your idea is incorrect. And if you fail to prove it wrong, then it's probably right. Now, common question here is, Mr. Gucci, shouldn't I be out there looking for evidence that proves my hypothesis? Now, here's where you should be careful, okay? Because if you only go out there looking for evidence that your idea is true, then you're probably going to miss a whole lot of evidence that might prove that your idea is wrong. Okay. So here's an example of an experiment. Okay. An experiment could be have someone sneeze, cough, whatever, talk while wearing a mask and while not wearing a mask, and track how many spit particles are sent flying into the air. Well, guess what? This experiment was done. Here is some footage of it. Okay. This is atmospheric music. I'm going to skip right to the grand finale because we want to be done with this. So here we go. The effect of masks on sneezing. Now, they broke it up into four different categories here, okay? Four different categories, and they are people without a mask, people with a one-layer fabric mask, people with a two-layer fabric mask, and people wearing an official surgical mask, the ones that you see that go over the ears and stuff. So let's see what happens when different people sneeze wearing these layers of protection. And just in case you're wondering, guys, that's what you look like when your sneeze is slowed down. Okay. Disgusting. Disgusting. So, yeah, what we could clearly see here, if my thing will just stop being slow. Yeah, we good? We good, computer? Thank you. Thank you. Yeah. So what we saw there is that without a mask, you're sending infected particles everywhere. All right. Even with a one layer cloth mask, like if you're just walking around with your shirt over your face, all right, you're doing something, but it could be better. A two-layer mask is better, and an official um, you know, surgical face mask is best. Not even an N95. This is not an N95 mask. It's just like one of those like folded papery masks that you put over your ears. Okay, so clearly this experiment worked. And then last step, you come up with a conclusion. Okay, you come up with a conclusion. All right. And this conclusion is you just share your results. Just share your results with people so that they can look at your results as well and either agree with you or maybe have ideas about how your test could be improved. Okay. So, for example, the conclusion here was the evidence shows that masks reduce the transmission of the virus by reducing the spread of disease carrying saliva drops. Fantastic. That's a good conclusion. But the conclusion could also be I critique this outcome because it does not account for people putting masks on incorrectly or for poorly homemade masks. All right, we should run more tests with these factors. All right, or your conclusion could be both of these. Hey, this supported my hypothesis, but there's still some things I'm unsure about. And sure enough, further research has been done to count the droplets with different type of masks. Other research has been done testing different types of fabrics and which fabric is the best type to make masks out of and which ones are the worst. All right. Now, once you've done all this, once you've had an idea, tested it, and failed to disprove it, meaning that it could be true, you have what's called a theory. A theory is an explanation of why natural phenomenon behave the way it does, why the world is the way it is. And while everyday language we use the theory to mean a guess, all right, in science it means something extremely different. Any idea you come up with is not just a theory, that's a hypothesis. A theory has to be tested, all right? You have to be able to make accurate predictions. We have this idea about, oh, I believe that wearing face masks can prevent the spread of COVID because it reduces the spread of infected droplets leaving your mouth. If this is true, then Places where there's a higher level of compliance with people wearing masks will have lower rates of COVID. And in fact, this is true. All the major outbreaks that occur are occurring because people are not following distancing rules and are not taking precautions like wearing masks. Is there more research that could be done? Yeah. But this theory that wearing masks reduces COVID spread because it prevents the spread of infected droplets, it's making accurate predictions. Now, one last thing for this notes here, the idea of a law. Okay, a law is a concise statement about how the universe behaves based on observation. Okay, a law is different than a theory. Okay, a theory explains why something happens. Okay, a law just states that something happens. Oftentimes it's a formula. Okay, something like that. Like a law could be, like, let's say we just realized that people wearing masks didn't catch COVID and we didn't know why. We could just make an observation that says wearing masks prevents COVID. And that could be the mask law of COVID prevention. It doesn't explain why, though. So it's not a theory. A theory has to explain why something happens. A theory is better than a law because it explains why. A law is not like a super duper theory. A theory is, in fact, the best possible thing. We already learned about a law, by the way. We learned about the law of conservation of mass, which says that you don't create or destroy substances, you can just change how they're arranged. All right? Doesn't say why, doesn't explain it. It just states a fact. So that is a law. A theory explains why. All right? A theory is based on extensive testing using the scientific method. A law is just a fact. And with that, if my computer will quit, I have a stupid slow computer, guys. And I'm too lazy to cut out the dead time at the end of this footage, so you're just going to watch it. Bye.